Hello everyone. So in the previous videos, we have seen the three different strategy for handling deadlock. The first one is deadlock ignorance, in which we use ostrich approach method to ignore the deadlock. Second one is deadlock prevention. In deadlock prevention, we use to disable at least one necessary condition for which cause deadlock problem. Okay, the necessary conditions for causing deadlock problem is mutual exclusion, hold and wait, circular wait, and no preemption. The third strategy is deadlock avoidance. In deadlock avoidance, we use Banker's algorithm to detect whether we go to a safe state or we go to an unsafe state. Okay. Now the last strategy, which is deadlock detection and recovery strategy. Before discussing deadlock detection and recovery strategy, we have to understand a new concept called resource allocation graph. So in Banker's algorithm, we see the tabular form to understand the problem of deadlock or to show whether a particular number of processes is in safe state or unsafe state. So tabular form is very good to find whether a particular number of processes is in safe state or not, because if there are more number of processes, then tabular form is good, but if there are less number of processes, then the graph, which is called resource allocation graph, is good. So in resource allocation graph, so first of all, what is graph? Graph is the combination of vertex as well as edge. Okay, so we have to cover the vertex part as well and edge part as well. So let's see the first vertex concept. In vertex, if you represent the process vertex, then process vertex is represented by a circular shape. So in circular shape, we use the process number. Okay, here pi given, here I represent to any process number. For example, if I want to represent process P3 as a vertex, then I will use P3 inside the circular shape. Coming to the resource vertex, resource is generally classified into two categories. One is the single instance resource and the other one is multi-instance resource. Single instance means there is only a single type of instance is available for that particular resource, and multi-instance means there are more than one type of instance available for that particular resource. For example, in single instance resource, generally CPU is considered as a single instance resource. So resource vertex, the resource is generally used with the help of rectangle shape. Okay, so whenever you use a graph, in graph process is represented in circular shape and resource is represented in rectangle shape. In single instance, there is only one dot present inside the rectangular shape, but in case of multi-instance, there are more than one dot present inside the rectangle shape. And multi-instance example is register. Okay, so there are more than one register are available in the particular computer. And if you study the digital electronics or microprocessor subject, in those subject we have studied, there are generally 32 general purpose registers available in our computer system. Okay, so register is nothing but a multi-instance resource and CPU is a single instance resource. Now let's go to the edge part. So edge is classified as assign edge and request edge. What do I mean by assign edge and request edge? Assign edge means the particular resource is assigned to the process Pi, and request edge means the process Pi is requesting for the resource Ri. Okay, so here you can think of it as register Ri here, and here also register Ri. So assign means this particular register Ri is assigned to the process Pi currently. Okay, it is held by process Pi, and here the register Ri is currently free, and process Pi wants this register Ri, so it requests for register Ri. Okay, so keep this concept in mind. In the next video, we will see the two different types of resource allocation graph, which will help to detect whether a particular state is safe or unsafe, and based on that state we can decide whether it is in it caused a deadlock problem or it does not cause deadlock problem.